So in your exams, you can also be asked to calculate the volume of a pipe. So pipe looks like this. A pipe has an inner radius, we can call it R, and an outer radius, we can call it capital R. A pipe is hollow, and to calculate its volume, we use the formula volume of pipe equals pi into the outer radius squared minus the inner radius squared into the length of the pipe, which we call L. So basically, this is the length L of this pipe. Now, let's talk about a cone. So a cone has a curved surface and a circular base. A cone has a certain height which is measured perpendicularly from its base, and the circular base has a radius r, small r. We also have the slanting height of a cone. We call that L, and we call this perpendicular height h. To calculate the volume of this cone, we use the formula volume of cone equals 1 by 3 into area of base into the height of this cone. So 1 by 3, we know that the base is a circular base, so that gives us the area of a circle pi r squared into h. And finally we get 1 by 3 pi r squared h. So sometimes we don't have the value for h or r. So in that case, we're going to use the Pythagoras theorem, c squared equals to a squared plus b squared, to find the missing values. Now, how do we calculate the curved surface area of a cone? For that, we have the formula closed surface area of cone equal to pi r L. So when we calculate the closed surface area, we're basically calculating only this area of the figure, excluding the circular base. To calculate the total surface area, including the circular base, we use the formula total surface area of cone equals to area of the circular base plus the curved surface area that we calculated before. So this gives us area of base, which is basically a circle, pi r squared plus pi r L. So now we're going to talk about a sphere. So sphere looks something like this. It's a 3D figure, and it has a certain radius from its center to its circumference. We call that r. So r is equal in all directions from the center of this sphere. To calculate the volume of this sphere, use the formula 4 by 3 pi r cubed, where r is the radius of this sphere. To calculate the volume of one hemisphere, by that we mean this area, we use the formula volume of hemisphere equal to 1 by 2 into the volume of sphere. So basically we're calculating the volume of half of this sphere. So we multiply the volume of the sphere with 1 by 2, which gives us 1 by 2 into volume of sphere, which is 4 by 3 pi r cubed. To calculate the curved surface area of a sphere, we have the formula 4 pi r square. To calculate the curved surface area of one hemisphere only, we just need to have the original curved surface area, which is 4 pi r squared. 4 pi r squared. This gives us 2 pi r squared. Now, the total surface area of a sphere is the same as its curved surface area. This is because a whole the whole of a sphere is a curved area. So we have 4 pi r squared, and similarly the total surface area of a hemisphere is half of that of the sphere, half of 4 pi r squared, which is again 2 pi r squared. But for this we also have to take into account its circular base, basically this area. So we add in pi r squared for the circular base. So we get 2 pi r squared plus pi r squared. Now we have a prism. So prism looks something like this. So a prism has a perpendicular height. We'll call that h. It has a length and breadth. To calculate the volume of this prism, use the formula volume of prism equal to area of cross section into the length of this figure. So that gives us half into breadth into height, which is the area of the cross section, which is basically a triangle. So we're going to use the formula for the area of a triangle. And for height, we obviously have this height of uh, the prism. For the total surface area of this solid, we're going to use the formula area of rectangular base, because the base is rectangular, and add that to the area of the two identical triangles on either side of that base. And add that to the area of slanting rectangular wall, which is basically this area right here, this shaded portion. So now we're going to calculate the total surface area of this solid. I'm going to draw this figure again. We have a hemisphere which has a radius of 10 centimeters. We have a cylinder which has a height of 25 centimeters, and we have a cone at the bottom which has a height, perpendicular height h, and a slanting height to be 22.36 centimeters. For this whole figure, we have a total height of 45 centimeters. So now let's calculate the total surface area for this whole figure. So that means we have to calculate the total surface areas for these three figures. Now note that for this cylinder, for all these three figures, we're not going to take into account these circular bases or these circular faces. So we're only going to calculate the curved surface area for the cone, for the cylinder, and for this hemisphere, because these circular bases do not form part of this surface area. So we're going to calculate the curved surface area for the hemisphere. We'll add that to the curved surface area for the cylinder, and then we'll add that to the curved surface area for the cone. So the formula for the curved surface area of a hemisphere is 1 by 2 into 4 pi r squared. We're going to add that to the curved surface area of a cylinder, which is 2 pi r to h, and then we'll add that to the curved surface area of a cone, which is pi r l. We know all the values, we're just going to plug them in these formulas. So we get 2 into pi into r squared. R is 10, so this becomes 10 squared. We'll add that to the curved surface area of the cylinder, which is 2 into pi into radius, which is 10, into the height of the cylinder, which is 25 centimeters. And then we have the curved surface area for the cone, which is pi into radius, which is again 10, and then we have the length, which is 22.36 centimeters. Now calculating this, so the curved surface area of the hemisphere turns out to be 628.5. The curved surface area of the cylinder is 1571, and the curved surface area of the cone, we have 702.5. Now adding all of this, we get the final answer of 2902 centimeters squared. So this is the total surface area of this whole figure, which we calculated by calculating the curved surface areas of these three figures separately.